Alright, let's go ahead and get started with this lecture video on heat energy. In this lecture video, we're going to focus on what heat energy is and the important concepts that are associated with heat energy. I would really take your time with this lecture video. Heat energy is a really important concept. You must have it well understood before you move on to any other lecture videos. Alright, so let's begin with defining what heat energy exactly is. By definition, we define heat is defined as the spontaneous flow of kinetic energy from an object of higher temperature to an object of lower temperature. Alright, so let's look at that a little bit closer because that's a really important definition. First of all, heat energy is abbreviated, or we use a symbol Q. So if you ever see a lowercase q, we're going to associate that with heat energy. Okay, 2. Spontaneous flow. What does spontaneous mean? Well, the word spontaneous means that it's going to naturally happen. It's going to naturally occur without any outside influence. Alright, so what this is really saying that is heat energy is really kinetic energy, but it's a special type of kinetic energy because it's dealing with kinetic energy that is being spontaneously transferred from a hot object to a cold object. Alright, and that will always occur from hot to cold. Alright, so what we're really doing is when we think about heat energy, we must think it in terms of kinetic energy that is being transferred between two objects that are at different temperatures. And if you can remember that, you're in good shape, especially understanding that it is from a hot to a cold, or from higher temperature to lower temperature, the heat is transferred into. Alright, now let's go ahead and model this, because it's such an important concept. You have to recognize and understand models of heat transfer. So we're going to use these two boxes for our example. So let's say that in this box over here, we're going to draw in some circles, and these circles are going to represent molecules or atoms that make up this system. We're going to say that the temperature of this system is 1000 Kelvin. Okay? Now, because of the amount of kinetic energy these molecules are going to have, they're going to have a fair amount of energy, so their speeds are going to be pretty good. So we're going to draw arrows here, and they're going to be kind of long. Also, these are called vector arrows. And what these arrows represent is the speed at which these molecules have. And the larger the arrows, the faster they're moving, or the more kinetic energy they have. Now over in this other box, we're going to say the temperature is 300 Kelvin. So that's a lower temperature. And so the atoms or molecules that make up this system, their arrows are going to be shorter. Why? Because they don't have as much kinetic energy, so therefore their speed is slower. Alright? So when you see the arrow notation like this on a test or a quiz, compare the two systems. The one that has the larger arrows is the ones that are moving faster and have the more kinetic energy. So we have our two systems. They're in contact with each other. They're both at different temperatures, so obviously there's going to have to be a flow of kinetic energy. And so which way is the temperature going to move or transfer? If you said from the higher temperature to the lower temperature, you would be correct. All right, so heat energy is always moving from the hot object to the cold object. And we can use the symbol Q to represent heat energy as it's being transferred. All right? Now, what's important to note is that that heat energy is going to continue to be transferred from the hot object to the cold object until both objects are at the same temperature, which means that they both have the same amount of average kinetic energy. Now you can think of this in relation to yourself. On a very cold winter day, when you go outside, you begin to feel cold because you are a object or a system that has a lot of heat energy. Your temperature is much higher than the temperature in the outside environment. So what happens is your body immediately begins to transfer heat energy to the outside environment. And when you start losing energy, you begin to feel cold. All right, so that's kind of an example of this heat transfer from a warm object, which you are, to the cold object, which is the surrounding temperature in the environment. On the flip side of this, on a warm, sunny summer day, when you go outside, you're going to start feeling hot, and that's because the outside environmental temperature has more energy, kinetic energy, than you do. And so energy from the environment is going to be transferred to you, and you're going to start heating up, and you're going to start feeling pretty hot. Okay? So there's a couple of analogies for you. All right? But also do remember that the transfer of energy is going to continue to occur until both objects are at the same temperature or have the same average kinetic energy. All right? All right, I think we've nailed that, so let's move on. All right, so heat energy, we give it a special sign. So if heat energy is transferred, oops, let me erase that. I want to highlight that. If heat energy is transferred from the system to the surroundings, then the total internal energy of the system decreases. By convention, the system loses heat energy, and we give it a negative sign. All right, and so we're going to indicate that concept right here. All right, so we have our system. Wrong marker. So we have our system. Right? And we're going to say that our system has more kinetic energy than the surroundings. So all out here would be more or less our surroundings. Right? And so if the system has more energy than our surroundings, then heat energy is going to be transferred out of the system into the surrounding environment, like so. And so Q is given a negative sign, meaning that heat is leaving the system and entering the surroundings. And so when heat energy always goes from the system to the surroundings, we will always give heat a negative sign. And that's important to note and understand. So the overall internal energy of our system is decreasing, and the surrounding environment is gaining more kinetic energy. All right? Hopefully that makes sense. All right, so let's look at our next skill here. In flip side of this whole thing, if heat energy is absorbed by the system from the surroundings, the internal energy of the system increases now. And by convention, if heat energy is absorbed by the system, then the system is given a positive sign for indicating that heat energy is coming in to our system. Okay, so let's take a look at that situation. Okay, so again, we have our system here, and we have our surroundings. Oops, spell that wrong. Okay, so now we're going to look at heat energy actually coming in to the system from the surrounding environment. When that happens, then Q has a positive sign when it's going into the system. Alright? And therefore the system's internal energy is increasing and the surrounding environment is losing heat energy. So in this case, the system should be warming up. It should start feeling hotter and the temperature should start rising as the energy is going into the system. Alright? So hopefully you can think of these concepts, re-look over your notes, really understand this concept of heat energy because it's really important, especially the signs and the relationship of heat energy from the system and the surroundings. Alright, so that is it for this lecture video.